Hello everyone, hope you are all doing well. So we are going to begin the live for this week. So this week the plan is that we want to revise the videos that we did on last 2 weeks because last week we didn't have any videos on, probably because of some technical challenges. This week we will have our videos, right, to be able to look at some graphical solutions for parabolic functions and graphical solutions for linear inequalities, and it'll be very interesting. So ensure that you are there to watch all of them. Create your notes, comments when it's possible, right? So we are going to consider the elective mathematics WASSCE 2025 question 11, which is in the area of the things that we have done. And then once we are done, we will also look at something very interesting, how we can model linear functions to be able to solve questions. We want to be able to interpret linear functions, know what it means when we talk about the gradients proper, and then know what it means when we talk about the y-intercepts, and then as well as know what it means when we talk about the x-intercepts and how we can interpret that in our real life. So I believe that with your new curriculum, that is the type of questions that you'll be getting. So you need to get yourself familiarized with such questions so that when you are solving them, you know what you are doing. They are easier to solve because they represent being able to find meaning to things, right? Find meaning to topics that you do, and not necessarily solving things algebraically, right? So let's consider this question. It talks about the question on functions. It says that given that the function f of x, right, implies x all over x squared minus 1, and we have g of x, which implies x all over x plus 2, where x is a member of the real number system, right? We must find the inverse, g inverse of x. So the first part, that is what it means. It is the inverse that they are asking for. And then we must find the composite function g inverse of f of x. And then we must find the largest possible domain of g inverse of x, right? So we want of f of x. So let's look at how we can solve this question. So basically in the question we have been given functions. So we want to write the functions out. So we know that one of the functions that we have been given is f of x. So we want to write it in this form. And then we know that that f of x is equal to x all over x squared minus 1, right? And we see where x is not equal to 1. We know why x is not equal to 1. We know that when x is equal to 1, the denominator becomes 0 and the value of the function becomes undefined, right? And we've also been given j of x, and we can write it as x all over x plus 2, where x is not equal to negative 2, right? So the I part of the question, which was the WASSCE question they wrote 2025, the question 11a, the I part of the question, we have to find g inverse of x, right? So g inverse of x. So we know the steps. We can say let y be equal to g inverse of x. So that implies that y will be equal to x all over x plus 2, right? And we know that the next step we must interchange the variables. So wherever we see y, we put x there, and wherever we see x, we put y there. So it becomes x is equal to, right, y all over y plus 2, right? Then we are going to simplify and make y the subject. So we are going to have x multiplying y plus 2, right? And that is equal to y. So we are going to have xy plus 2x is equal to y. Now we'll move all the y to one side. So we have xy minus y is equal to minus 2x, right? So we factorize y out and we get x minus 1 is equal to minus 2x. Then we can divide both sides by the coefficient of the y, which is x minus 1. Then the coefficient of the y, which is x minus 1. Then we have our y to be equal to minus 2x all over x minus 1. Now remember that it's important to state the domain of this function as part of the solution when you are finding the inverse. So we can say that the domain, right, x such that x is a member of all real numbers. We know when we equate x minus 1 to 0, we get x is equal to 1. So where x is not equal to what? 1, or except x is equal to 1. So we include the domain, right? So with the marking scheme, you get a mark for including the domain, you get a mark for being able to write the inverse, right? When you write it as y is equal to minus 2x all over x minus 1, you can even as well write it as j inverse of x to be equal to minus 2x all over x minus 1, right? So that it looks nicer. Then you get some marks for being able to adjudicate or being able to solve the algebra part of it. So a mark here will do. So probably 4 marks for this, right? And then in the II part of the question, we have to find the composite function J inverse of f of x, right? So after this, I would include one question where I'll see if you'll be able to get the answer in the comment section. So it means that what we are going to do is that we'll take J inverse, and wherever we see x in J inverse, we'll put f of x there. That is what it implies, right? So we now have J inverse. So if you don't get the J inverse correct in that question, it means that your composite function will also not be right? So it means that you are going to have J inverse, which is negative, right? So J inverse of f of x is going to be negative. Wherever we see 2, wherever we see x, we'll put f of x there, right? So f of x, right, all over f of x minus 1, right? So that implies that we are going to have our solution to become, right, negative 2. Substitute f of x there. So we know f of x is basically x over x squared minus 1. So we have negative 2 multiplying x over x squared minus 1, right? All this over, right, x over x squared minus 1 minus 1. So that is J inverse of f of x, right? So the negative 2 multiply the numerator part. So we have negative 2x all over x squared minus 1. We can write the division sign as this so that it becomes easier for us. X all over x squared minus 1 minus 1. So we put this into brackets, right? Let's say we put this as well into brackets. So that is J inverse of f of x, right? So it implies that to be able to solve this, we must be able to work out the left-hand side of the equation or the right-hand side of the equation as well. So x squared minus 1. And then on this side, we are going to have, right, x squared minus 1 as the LCM. And this will give us, right, x. Then minus this side, we will have x squared minus 1. Right, so division, we can change it to multiplication. I have minus 2x all over x squared minus 1 multiplying x squared minus 1 all over x. The negative affect the x squared becomes minus x squared. Negative negative becomes positive what? 1. Right, so x squared minus 1 will cancel x squared minus 1. Then we get to have our J inverse of f of x to be equal to, right, negative 2x all over x minus x squared plus 1. Right, so what of if you are asked to find J inverse of f of 2? Right, what would that be? So go through this and find the value and put it at the comment section. I want to look at the answers that you get for J inverse of f of 2. So go through that, solve it, and let's see what we get for the J inverse of f of 2, right? In this case, they are giving us f of 2. They want us to find f of 2. So go through it and let's see what we get for J inverse of f of 2. In the next 2 minutes, right? This is very simple, so you should use 2 minutes. So I'll here as well. So you can decide to use a calculator, right? No answer. I'm waiting for an answer, or the first answer. Who will get it first? So we are looking for the solution of G inverse of f of 2, right? We are substituting 2 in place of x there. We want to look at the answer. Okay, so Calvin, as usual, has gotten the first. So Calvin says it's 4. Okay, so the answer is 4. And yeah, you are right. You're actually right. That's good. How about the others? Nathaniel, Collins. What solutions are you getting for G inverse? Okay, so Nathaniel is also getting 4. How about Collins? What do you get for G inverse of f of 2? So indeed, it's supposed to be 4. So it means that you are going to have G inverse of f of 2 to basically be G inverse of f of 2 will be equal to G inverse of f of x, right? In this case, x is 2, right? So we are going to have minus 2 multiplying 2 all over 2 minus 2 all squared plus 1. And that will give us 4, right? So Prince Bachi, you're also getting it right. It's going to be 4. That is very good. That is very good. Now, you see that the I part of the question, we are supposed to find the domain of the function G inverse of f of x, right? So you not being able to get G inverse of f of x will also affect being able to write your domain. So we know G inverse of f of x is minus 2x all over. Let's arrange the denominator. So we have minus x, right, plus x plus 1. So we know that minus x squared, right? So we have minus x squared plus x plus 1. We can equate that to 0. Then we find the roots of that quadratic equation. So we can use the calculator, go to equations, go to 5, and then go to 3. Then the coefficient of the x squared is -1, right? And then the coefficient of the x is 1. And out of the constant is 1. So we don't get constant values, but we get some decimal values. Or we can write them in their said form, right? So we know that our x should be equal to 1 plus square root of 5 all over 2. And x will be equal to, right, 1 minus square root of 5 all over 2. So we write the domain as x such that, right, x is a member of all real numbers, right, where x is not equal to 1 plus square root of 5 all over 2 and 1 minus square root of 5 all over 2. And you have been able to find the domain, right? So we have gone through the WASSCE 2025 question 11, and it's very interesting that you are able to do it, right, at Form 1. That shows a lot of promise. It really tells of how well you have practiced now. I believe functions will be one of the very, 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 very good ones for you, right? So that is very, very good. Okay, so some of you are writing it in the decimal form. That is also good, but then you should write all the 2 values, right? When you are stating the domain, you write all the 2 values. Now let's consider one of the most very interesting questions that I want us to look at today before we close. So with this one, I'm willing to take my time, right? So in the next 5 minutes, you can probably take a screenshot of the question, right? In the next 5 minutes, you can take a screenshot of the question while I read it, and then try and solve the question on your own. This is an application question which involves you being able to actually use linear equations in your real life, and it will help you to be able to know the importance of linear equation as you have done last 2 weeks. So the question says that Sarah is considering a new mobile phone plan, right? So in Ghana, we have mobile phone plans, and the plan has a fixed monthly cost of 15 Ghana cedi plus an additional charge of 0.10 cedi. In that case, it is 0.10 peso, right, or 10 pesos, or 0.10 cedi for every minute she spends on call, right? The A, write an equation to represent Sarah's total monthly cost, C, in cedis in terms of the number of calls, call minutes M. So all of you try the A part of the question, write the equation, the linear equation that will represent this model question, right? So now we are modeling, we are trying to look at how linear equations can apply to real life. So look at the question very carefully and model the equation for us. So we are modeling it in terms of the cost C, right? And in terms of the number of minutes called minute M, right? So model the function and write it in the comment section. Let's see your answers for the A. These are the type of questions you should really be able to do, right? It's important that you have knowledge of questions like this. It helps, right? So what will be your modeled equation in this case? And then the B, we are saying that using the axis provided below, right, accurately draw the graph of this equation. So we are drawing the graph for the interval 0 is less than or equal to M is less than or equal to 200 minutes, right? And then we must clearly label our axis, right? So the hint is that use a set X, which is x-axis M from 0 to 200, and then y, C, from 0 to 40. Okay, so Calvin has gotten an equation. Says that f of x is equal to 15 plus 0.10x. Calvin, rewrite it and then use C in place of f of x, and then you can use M in place of x, right? So you are asked to write an equation to represent it in terms of C and M. So we know we have f of x and x. So write it in terms of C and then in terms of M, right? And then you are right. But then the function you've written is the right function, just that you are writing the function in the old x and f of x that you know. In this case, they give us in terms of C, which is the cost, and then in terms of the minutes. Okay, so C is equal to 15 plus 0.10 m. That's very good. That's very good. The others, are you also aligning with his answer for the function? C is equal to 15 plus 0.10 m. Are you aligning with that? Now we want to draw the graph. So now we will go to look at the subsequent questions that are associated with it. So after doing that, you are asked to actually use your graph, right, to find and explain the meaning, right? So initially, sometimes you are asked to draw a graph, but this time the importance here is that we want to explain the meaning, right? So we want to use a graph to find and explain the meaning of the following context of the problem. So what does the gradient of the line, right, of your graph mean? What does it mean in terms of the cost of probably the phone call and the number of minutes that he gets? And then the C intercepts, right? The C intercept is the same as the Y intercept. So what does the Y intercept? What is it in the first place in the question? What does it mean, right? And then once we are done with that, we'll use that to estimate Sarah's total bill if she uses 150 minutes in a month, right? So we want to estimate the total bill of Sarah if she uses 150 minutes in a month. So let's consider how we can solve these questions. Whilst we go through this, I expect that you write the questions so that you would have it by your side, and then it helps you to be able to follow when we go through the solution. So if you've not written the question, try and go through writing the question or take a screenshot of it, right? It helps. So you can take a screenshot of the first part of the question and the second part of the question, whilst you use that as a way to be able to reference, right? So that is the first part of the question. Let's go to the second part of the question, right? And then that is the second part of the question. So take a screenshot of it so that we can use that to be able to solve the question, right? Okay. So if you've been able to do that, let's go through solving this question, right? So we want to solve this question. So first and foremost, what we must see is that we've been given, right, a very real world problem which involves somebody's data cost. So it says that Sarah is considering a new mobile phone plan, right? The plan is a fixed monthly cost. So we will fix a fixed monthly cost, which is equal to 15 Ghana cedi, right? We say let C be equal to the cost, right, of the plan in general, but it has a fixed monthly cost of 15 Ghana cedi, and then additional charge, right? So additional charge charge. The additional charge is 0.10, right? Ghana cedi, 0.10 Ghana cedi every minute, right? So we can say let M be equal to the number of minutes, right? The number of minutes. So therefore, the first part, the equation to represent it, we can say that the general equation, right? The general equation is of the form y is equal to ms plus c, right? Y is equal to ms plus c. Now, we know that the y is what we are representing with the c. So c is equal to y. And then the m, right, represents the minutes. That's what that one, we have it already. And then we have our c, which is a constant. So the c is the 15, right, cedis, right? So that is a 15 cedi. When we substitute, it means that we have our c to be equal to, right, 0.10 m plus what? 15. So the a, right, the a part of the question, our equation now will be represented as what? C is equal to 0.10 m, right, plus 15. Is that clear? So that is our C. So a very simple question, but without an understanding of the linear equation itself, it becomes very difficult for you to be able to actually solve questions like this. So as I said, your curriculum is expecting that you learn not just for learning's sake, but be able to apply it in real life. And that is the most important thing. It's not the algebra, it's not solving things, right? But being able to understand how we can apply some of these things to real life. So that is our C. That is the first part of the question. Now, the B is saying that using the axis provided below, accurately draw the graph of the equation. So we are drawing a graph from 0 to 200 minutes, right? And then the hint has been given to us. So let the x-axis be from 0 to 200 minutes and the y-axis, right, be from 0 to 4. So we are going to transform this into a graph right now. So we have our graph, and based on the graph, we are going to have our x and our y-axis. Let me leave this here so that so we can draw our x-axis. You see, these are opposite points, so we don't need to worry ourselves by having negative. So we draw our y-axis, and then we draw our corresponding x-axis, right? Yeah. Okay. So we could pick from 20, because it's up to 200. We go to 40, we go to 60, we look at 80, right? We will consider 100, right? We are going to consider 120. We are going to consider 140, right? We are going to consider 160, 180. Let me extend this line a little bit, and then before I do that, I have to move it up here a little bit. Okay, so we have 200, right? So we can have 200 here. Let me use the red, then 200, right? And then on this side we have up to 40, so let's use 5. So we can have 5, we can have 10, we have 15, we have 20, we have 25, we have 30, we have 35, and then we have 40. So you should also be drawing a sketch of it in your jotter, or even if you have a graph book, you pick your graph book so that you can be able to draw a sketch of it, right? That would help you, right? So ensure that you draw a sketch of it. It helps, right? So that is it. It looks very nice, right? So you are going to pick, right, any ordered pair of points for x and y, right? In this case for C and for M, so that we'll be able to get values for C. So let's assume that probably in this case right? He did, let's say, 20 minutes. So I'll start from 20 minutes. So if M is equal to 20, what will be our C, right? So if M is equal to 20, what will be the cost of the plan, right? So we will substitute 20 in place of M. So it means that our C will be equal to 0.10 multiplying 20 plus 15. So it means that our C will be equal to what? So we will do these ones, and when we finish, we'll come and use that to draw the graph. So we are going to have 0.10, right? So we have 0.10, 0.10, right? Multiplying 20. And that should actually give us 2 and then plus 15. So that should give us 17. So it means we have our cost to be 17, right? This represents our M and this side represents our C. We'll come back to the graph, right? So let's pick some ordered pairs. So we can have M to be equal to 40, right? And let's look at what the C gives us. So it means C will be equal to 0.10 multiplying 40 plus 15. So it means that we'll have 0.10 multiplying 40, which will give us, right, multiplying 40 is going to give us 4, right, plus 15. So it means we get 19. So it means that our C is equal to 19. So we have 20 going with 17, right? We have 40 going with 19. Let's look at 60. So if M is equal to 60, it means that our C will be 0.10 multiply 60 plus 15. I hope you're also going through the same process, right, to be able to get them. So we have 0.10, right, multiplying the 60, right, plus 15. Let me probably pause here and see what you get. What do you get for that one? Put the solution for that one in the comment section and let's see. When you have 60, right, what would that one be? So it means that with that, we are going to have our C to be equal to, right, we have 0.10 multiplying 60 plus 15, which gives us 21, right? And then we could probably add one more. We can add 200, right? So if M is equal to 200, what is our cost C? So we have, very good. So 21, Calvin, you got in it. That's good. 21. Nathaniel, right? 21. That's very good. 0.10 means you are following. Multiplying 200 plus 15. So put the solution for that one there as well. 0.10 multiplying 200 plus 15. 0.10 multiplying 200, right, plus 15. Very good. So that is 35. So it means C is equal to 35. So in this case, we have 200, right, going with 35. And then we also have 60 going with 21, right? So we want to plot the other pair of points that we have here. So we are going to pick them one by one. We are going to pick our other pair of points. The first one is 20. So 20 is for the minutes and 17 is for the cost, right? So like 20 minutes, 17 cedis. So 20 minutes, 17 cedis, 15, right? So this will be 17.5. So somewhere here, right? So somewhere here, we put our point there. And our next one is going to be 40 going with 19, right? So it means that 40 goes with 19. So 19 is almost close to 20. That is here. Very good. And then our 60, with this 60, right? 60 goes with 21. So 60 goes with 21. So there's not much increase in terms of the price, right? 60 goes with 21. Is that what we got? So when it was 60, so when we multiply by 15, so 0.10, right? So that goes with 21. So it means 60 will go with 21, which is here. Where is our 21? Where is our 21? So that's here, somewhere here. Okay. And then finally we have 200 going with what? uh, 35, right? So 200 here goes with 35, which is up here. So that is up here. So 200 goes with 35, which is here, right? So we can have a line. So this 15, this 17. So the line passes through. I mean, I didn't plot the second one well, so we'll come back to plot that. So we want the line to pass through the points here, right? So we'll put the line through, right? So let's check this point again, right? What does, oh, okay. So I put the 40 at somewhere 30, that's why. So it means that this has to be at 40, right? That's why. So this 40, right? So somewhere here. So the equation of this line, right, we know is C is equal to 0.10 m plus 15, right? So we've been able to draw the graph. So this is a graph, right? Being able to put down the scale on the vertical and the horizontal axis basically means that we've been able to get our graph. So that is a graph for the question. So that represents the graph of the question. Now, the most interesting part is where we are coming to. So we want to look at the C. So I want to find out your understanding of these things. We've looked at them already. In the lessons, we've considered what the gradients represent. We've considered what the y-intercepts represent. So now that we have looked at the graph, in the first place, what is the gradient of the graph? What is the gradient or the slope? What is the gradient or the slope of the graph? Write it in the comment section and let me see. What is the gradient or the slope of the graph? Right, I want to know, what do you understand by the gradient or the slope of the graph? What value is the gradient or slope of the line or the graph of the line? Right, so yes, put your answers there before we continue. What's the value of the gradient or the slope of the line? So CI. What is the value? So what's the value of the gradient or slope of the line? I'm waiting for an answer. Okay. So someone has written that as M to be equal to 0.10. Okay. So the gradient is 0.10. Do you all agree? Calvin, are you also with us? Nathaniel, are you with us? Do you agree that it is 0.10? Right, so very good. So the gradient is 0.10. Now, it is not enough to know the gradient. What does the gradient, right? Now, what does the gradient represent when it comes to the cost of phone call and the amount of money he pays? What does it represent? So type something there. I want you to explain what the gradient represents when it comes to the cost of the phone call and basically the amount of money that he is supposed to pay. What does it represent? So that is the most important thing. Once you are able to know what the gradient represents, then it means that you are probably been able to understand it very perfectly. It means your understanding is on probably the 90% when it comes to linear graph. So what does it represent? Write a statement there or write a sentence there. What the gradient represents. These are the type of questions you get when it comes to the international types of curriculum, the CAMRACE, the IGCSE, right? And now with our curriculum, God being so good, we are now able to look at modeling things and being able to interpret things. So we want to look at what it represents, right? Okay, so Prince Bachi is saying it represents the number of minutes. Oh, you have tried, but not necessarily. Yes, I need other solutions. What does the gradient represent? It doesn't necessarily represent the number of minutes. It doesn't necessarily represent the number of minutes. Gradient itself represents something. So in terms of the cost and then the minutes, we want to look at what it represents. What does it actually represent? Right, what does it actually represent? You should be liking the life, right? Giving us emojis if probably the explanations and what we are doing is really going with you. You can choose a love symbol, you can choose the symbols and put them there, right? But I want to see, what does the gradients represent? I want more suggestions. Tell us what the gradients represent. You see, this is where we are struggling. We understand the algebra, but we really do not have much understanding about the meaning of the algebra. Calvin, give us what if it's okay. So Calvin is here. Calvin is saying the gradient represents the steepness, okay, of the slope of the line, like how much it increases. Well, you've explained the gradient in general terms. But then you've been given a model question. We are talking about the cost of probably a phone call and the amount of money the person pays. So we must be able to write it in terms of that, right? So we can say that the gradient, right? So we say that the gradient, the gradient represents the rate of change, right? The rate of change. You realize that when the m changes, right, in respect to the gradient, it affects the c. So it represents the rate of change of, right, the cost of the plan with respect to right, the minutes, right? So Collins have probably given us something closer, right? So the increase in the number of calls with respect to the cost, that is it. That is very good. So we are looking at the rate of change, right? The rate of change of basically the cost of the plan with respect to the number of minutes. So that is what the gradient represents, because once it is increasing, right? Once the slope is increasing, realize that the cost that you are going to pay would continue to increase. So we see that over here, once it is increasing, the cost you are going to pay will continue to increase. So we see that when you end up spending 200 minutes, you have to pay some amount, right? You have to pay something higher, and so on and so forth. So that is what it actually represents, right? So that is what it actually represents. And then what does the y-intercept represent? So the y-intercept, right? So what is the y-intercept? Basically, the y-intercept is considering, when you have an equation, the y-intercept is considering, right, when you have c is equal to 0.10 m, right, plus 15, the y-intercept is the 15 year, right? So it's a value of probably the c when the x is equal to 0, right? The value of the c when the x is equal to 0. So interpreting that, it means that it tells us of the amount of money that is supposed, or the fixed amount of money. So the y-intercept represents the fixed amount of money, right, that Sarah is supposed to pay at the beginning, because at that point x is equal to 0, right? At that point x is equal to 0, right? But y is at 15. So at the beginning, right? You see, when x is equal to 0, the slope of the graph will come to the 15 year, right? The 15 year. So the 15 year represents the y-intercept. And in terms of the interpretation, that we say that it talks about, right, the fixed cost. So it represents the fixed cost, right? It represents the fixed cost at time t is equal to 0. So that is the fixed cost at time t is equal to 0. So I believe that when you have gone through this live, right, if you've been able to follow this live, from now on, when we mention something that is called y-intercept, you should be able to know what that y-intercept actually represents in real life. So it's not just about knowing the value of the y-intercept. You should be able to interpret that in real life. And these are the type of questions you will be getting, right? So they are very easy once you understand the concept, once you can be able to apply the concept. You should be able to solve these type of questions very well. Now let's consider the last part of the question so that we'll be able to probably finish for today. You've done so much. You are doing so well. You are doing so well. So you are asked to use a graph to estimate Sarah's total bill if she uses 150 minutes in a month, right? So you can estimate that yourself and write the value there. It means that you are going to trace 150 minutes onto the time, and then we indicate what that represents, right? So we use our line, we will trace from the 150 minutes, right? Let me bring it up here so that I can see well. So we trace 150 minutes. We can use short dash lines, right? So we trace with short dash lines. Okay. So we move short dash lines. So what would that be? Right? What would that be? When we trace it to the x, what would that be? So it's exactly here. So we want to see what that gives us here. Right. Okay. So it means that, right, very good. So you are going to get 30. So you are going to move from this side, right, short dash lines. So, and then we are going to, right, put an arrow there. And we see that it's directly on the 30, right? When we put the arrow there, it's directly on the 30. So it means that we can conclude that, so these are CI, these are CII. It means that we can conclude that for D, right, it means that they are going to, he's going to pay, Sarah will pay 30 Ghana cedi, right, after 150 minutes of calls. So what we have looked at today should tell us very clearly, right, that you can have a business, you can create an entity or a business where you can model that business on a linear function, right? You are probably looking at how you can charge someone, and then you are charging based on a fixed fee and then some variable fees. We can use, right, a model to be able to determine how much you charge for your service, a fixed fee, and then an additional fee for probably every number of hours that you spend. And that will help you to be able to probably use that to program something for yourself, right? A very good workspace for yourself. So if you are in IT, you use that. The math knowledge will help you to be able to use that to program something. So we have looked at several things today. We've solved the question WASSCE 2025 question we got on functions, which are things that we are doing. And we've also looked at how we can solve a question, a model question on linear equation, which are things that are on our video, right? And I believe that today you've learned a lot. It's important that you learn this way because that is the way to go now. So you should be able to follow and learn in this way. Now, for Monday, we'll be loading more videos. We'll be putting videos on the parabolic functions as I've mentioned earlier. And then we'll also be putting videos on the inequality, right? For one variable, for two variables, right? And then subsequent weeks, we would continue to look at polynomial functions, and we'll look at rational functions. And then we also have videos on all the other topics as well, but we want them to be arranged well. That's why we have not put them there. So once we are done with the functions, you see videos in core maths, in mathematics, in additional maths, on all the other topics that you have to do, right? So you can be able to watch it anywhere, wherever you are. Ensure that you watch it, right? So that is it. Okay, so Prince wants us to go over again. Oh, okay, that is fine. So as Calvin is saying, the best thing you can do is that play the whole video again. Play it so many times, as many times as you want, right? We have taken our time and carefully explained it. So play it as many times as you want. It will help you to be able to understand it. the life will be there all the time. Once we end the life, it will be there all the time. It can help you to be able to understand it, right? Okay, that is fine. So you can play it over, understand the question, and then it will help you. So as I said, we would have more videos, and then ensure that you follow me at all times. Let's journey through this journey, and then probably after 3 years when you write your WASI, what I want to see is that you would have testimonies that probably you watch these videos and it helped you a lot. It made you a very better person in mathematics. Thank you so much for joining us, and we'll meet again next week Saturday 6 o'clock to 7 o'clock. Once again, my name is Nana Idu, and you can call me Senana. Thank you so much for coming. Thank you so much for coming. You've done well. Thank you so much.